It is time to start with the second keynote speaker of this today's conference. I have the pleasure to introduce to you Mr. Paul-Emmanuel Brun from Airbus Cybersecurity France. He is going to provide a talk on securing low-power device communication in critical infrastructure management. Paul-Emmanuel is a passionate of cybersecurity, IoT, and identity management. He is an expert in IoT system security, and he leads the innovation activities within Airbus Cybersecurity France. As a former security and identity management engineer, Paul-Emmanuel was involved in several European initiatives and contributed to several projects to the French Ministry of Defense, from secure architecture definition to integration of cybersecurity solutions. After applying several patents linked to cybersecurity of IT and IoT systems, he is now focused on innovation and IoT system security. With Airbus, Paul-Emmanuel is currently directly involved in the EU H2020 Brain-IoT project, where he leads the activities related to security, and he is also part of the European Security and Privacy Cluster.
So thank you, Enrico, for this very nice introduction. So we will have a short, quite short talk about the securing low-power device communication in critical infrastructure. And I will just start to give our view, at least from Airbus, regarding the threats into the IoT systems. So just to start quickly, how we see the threats today in IoT. We see three usages of IoT in order to perform cyber attacks. The first one is to use the IoT as a target itself. For that, I will take the example of Dallas emergency siren cyber attack in 2017, when a cyber attack was performed on the Dallas emergency sirens and make them run early in the morning. This doesn't seem to be very critical, but the fact is that this overflow the emergency call and create a kind of panic into the city. There is a lot of other examples regarding the IoT as a target of cyber attacks, such as, for example, in the car industry with the Tesla, the Jeep that were breaked. But this is, I think, a good example. The second type of attack is using the IoT as a vector. Indeed, most of the time, hackers are looking for the weakest point into the system they want to attack. And what we see is that most of the time, the IoT is one of these weakest points. In 2017, there was a quite interesting attack into a casino where hacker used a simple temperature sensor that was connected to some cloud application in order to go through this temperature sensor, go through the Wi-Fi of the system, and then to the database into the casino. This is very interesting to see that here. They use a quite simple device in order to retrieve all the data, to try to retrieve all the data from the casino. So here we can really see that the IoT is seen as a vector in order to target a much bigger system than the IoT itself. And the last one is that the IoT is also often used as a weapon. Typically, the Mirai botnet, who break the DNS 2 years ago, is a very good example of cyber attack. Why we can use it as a weapon? It is simply because there is so much IoT out there that are quite similar one to the others, that it is quite easy when you have found a security breach to take the control over lots of devices, and therefore you can use it as a real weapon. So now, if we go to the critical infrastructure and the industrial IoT consideration regarding cybersecurity, we can see that there is several kind of impacts of a cyber attack into IoT systems. The first one is the business impacts. Indeed, if a hacker succeeds to break an IoT system in the industrial and critical infrastructure context, this could have a huge business impact in terms of production and service downtime, in terms of quality of the production that is done, of the service that is delivered, and of course it could also cause reputational damages, because when a company related to critical infrastructure is known as have been cyber attacked, then for the reputation it could be quite terrible, and therefore it could be also a loss of opportunities and businesses for this company. The second point is the physical damages. In critical infrastructure, IoT is often used in the context of what we call cyber physical systems. So it means that attacking an IoT could cause equipment damages, and also in some context it could lead to some human safety issue. The production line is a good example. If you attack some robots within the production line, then you could have some human safety issue for the operators that are working, for example, in the factory. So this is a key point also in the critical infrastructure. And the last one is related to the damage to intangible assets. Critical infrastructure also could mean that you have a high level of intellectual properties to protect, and these intellectual properties could be, for example, linked to the production means you have, and that are often related to the devices and the IoT you have in the company. Just for example, when you produce, for example, foods, temperature is a key value. Why? Because it's a secret you have, so it's part of your intellectual property in order to make the food as you want to be at the end. So if a competitor succeeds to steal you the temperature of your processes, then it could be a high loss for you in terms of intellectual property and uniqueness into your own market. So the example I gave is quite simple, but we can also imagine the same in a production more industrial oriented or more critically oriented. And of course, we all know that there could be threats related to privacy issue and private data leakage. For that, for example, I will talk a little bit after about water management use case, but in all the energy management use cases, you have to face the management of some kind of personal data that are privacy sensitive. So this is also a real risk that we have to take into account in critical infrastructure, especially in the energy domain. So let's have a short overview of the IoT, let's say, quite standard system architecture. So I divided here the architecture into 5 blocks. The first one is the device on the left, the device itself. The second one is what I would call the edge network, so the network which is close to the device. The third one is the network provider. This could be the internet infrastructure typically. Then you have the IoT platform itself, or the IoT platforms that will collect all the data. And finally, you have the application and services that will serve the service for which the IoT and the devices are deployed. Along all this value chain, we can identify threats. It could be very hardware and physical threats on the device itself. It could be on the network by spoofing some untrusted data. Especially when you have when you are using non-secure protocols. But there is also threats on, let's say, third party that are providing services for the IoT network, for the IoT system, sorry, such as the network provider. There was some interesting example of hacking into telecom provider that show that leads, sorry, to a leak of a lot of personal and professional data through the 4G infrastructure. And we could also identify some threats on the IoT platforms, quite similar to the one on the network provider. And finally, this could lead to fake data sent into the application, and therefore an application that will not be able to create the service for which it is designed. Just in order to show you an example of this kind of threats, I made a little search on Shodan. Shodan is let's say a search engine that was made quite famous because it's the one which was used in order to reveal that there were a lot of IP camera that were fully open on the internet. And I made a small research regarding an IoT protocol which is quite widely used, which is MQTT. So it's a queue protocol, quite well known. Sorry. And making this research, I found that there were 74,000 of fully open backend on the internet. And by going through some of them, I saw that there were lots of backend that were related to IoT data, for example, GPS position, temperatures, humidity, some kind of actuators, and there were not any protection in order to access those data, but there were also not any kind of encryption on those data on those servers. So it really shows that the threats exist and that we have to take this into account when we are designing our systems. Just to conclude on these specificities of IoT on the top of those threats, we can also highlight some complexity that are really related to the use of IoT. The first one is the fact that there are a lot of heterogeneous protocols and with very different requirements that make very hard to ensure real end-to-end security as we can have today, for example, when we go on HTTPS websites. The second point is that we are using in critical infrastructure protocols and hardware that come from the mass markets and that are not, let's say, built specifically for critical infrastructure systems. This is necessary because indeed, if we want to build IoT services, we need to reduce the cost because we want to deploy lots of devices, and the cost is one of the drivers in order to build those IoT systems. But on the other hand, these have a huge impact on the overall security of the system because you introduce some weakness into your IT and OT systems. And the third, let's say, challenge that we have to face is that we see that we have very different use cases, even into what we call the critical infrastructure. We will see the Industry 4.0, the connected transportation, some use case related to smart city, to energy, and all that have very specific requirements that are not the same. For example, if we go to energy, if you want to deploy some gas meter, you will have energy constraints on it. But if you want to deploy an electric meter, then you will not have this low power, let's say low power requirement. So this leads to a lot of heterogeneity constraints that are very complex in order to take into account when you have the system view of the full IoT architecture. So just a short talk about what we call the end-to-end security. When we are talking about the end-to-end security, the idea of that is that you are able to ensure the security, the authentication, and the privacy of the data from the device up to the final application. We can, let's say, compare this to a kind of a VPN that will ensure the security of the data through all the value chain. So typically, you can, if you implement a trustable end-to-end security, you can rely on third party for your networks, for your platforms, and for your systems. This is really the added value of the approach of end-to-end security, and therefore you will be protected against all the threats on the third-party components. If we have a short look on the state of the art of this end-to-end security with a specific focus for low power, then we identified four main, let's say, protocols. The first one is TLS. TLS is quite well known. It's the protocol that is used, for example, when you go on the website of your bank. But the issue of this security layer is that it's quite heavy in terms of consumption, and it's also, and it's also quite, let's say, not adapted to when you have when you are using different protocol at different point of your system. And now if I go to EDHOC plus TLS, it's let's say enhanced use of TLS, allowing to use lower hardware in order to perform the cryptographic operation. This is a very interesting approach, but what we can see is that it's not covering this topic of end-to-end security when you have, let's say, heterogeneous protocol in the data flow. If I talk a little bit about the SEHC plus TLS, SEHC, it's let's say it's a compression algorithms in order to ensure the capability to use IP over many kind of protocols, such as, for example, LoRaWAN. This one is very interesting to ensure end-to-end security, but it doesn't support the fact that you will use in your data flow different protocols. For example, if you are using LoRaWAN, then MQTT protocol, then HTTP, it won't be able to secure all the chain without what we call hop-to-hop security, so decrypting and re-encrypting the data at each third-party component. And finally, there is the OSCORE protocol, which is also very interesting, but quite limited to co-op, and therefore it's not possible to have protocol disruption. So quite the same issue that for the previous one. So within the Brain-IoT project, what we have seen is that there was no really solution to ensure true end-to-end security, especially targeting to critical infrastructure where we want to have high trust into the data, even when they are going through some kind of third party that are providing services such as a network provider or even some platform aggregator providers. So we have worked in order to develop such kind of end-to-end security layer, and we have done that in the water management use case. Why water management? Because it's a very critical use case where you have to trust the data you received, and therefore this kind of security is quite well suited, let's say, to this this kind of use case. So I gave it here an example where we have two IoT networks and where we are sending data to the Brain-IoT fabric. And the idea is that we are able to encrypt over all the applicative layer the data that are sent, and we are able also to check this encryption and check the authenticity of the data when we received it into the system. Through the security management, we are also able to distribute the key, allowing therefore to comply with regulation that ask for regular key renewal and such kind of requirements. This shows that we are able to protect against any kind of attack on the third party. It means that if the network provider backend is hacked, all the data will be encrypted and authenticated. So if anyone is trying to spoof and to steal data in this backend, this will have no effect on the final system. This layer have a very low impact on the energy consumption, because we are the impact is about 0.25% of the whole device lifetime, and the impact on the bandwidth is also very, very low, because we are talking about 5 bytes linked to the security overhead. So just to summarize very quickly what has been done. So let's say this is quite legacy infrastructure where you have the Brain-IoT node, which could be compared to the final application, and between both you have your network infrastructure, either LoRaWAN or any other kind of network. Those networks are offering a first layer of security between the device and the network itself, and then they are offering a security layer in order to connect to their backend. But into their backend, the data are either non-authenticated or even more not encrypted. So that's the security layer we have developed allows to ensure this end-to-end security. And this, let's say, fully transparently, because all the keys and the key management is also exchanged through this network, and therefore you don't need any other kind of connection or any other kind of requirements. So to conclude, this was a short presentation related to cyber, we call cyber protection for the low power devices. But we need to understand that cybersecurity system rely on two main pillars. The first one is the cyber protection of the system, but the second one is the cyber detection. And here in the IoT systems, we have new challenges, especially regarding, let's say, legacy cyber monitoring systems. Because in legacy cyber monitoring system, we are relying on systems that don't have restriction on the bandwidth, don't have restriction on the power, and that are relying, let's say, on the quite well-known number of assets. Here in the IoT, we are talking about environments where we can see devices that are coming and coming into the system and out of the system regularly. We are talking about network protocols that have very different bandwidths. So it's really new challenges that we have to face in order to monitor those kind of systems. And for that, the last point is that it's a very decentralized architecture. Therefore, that's why we think that the artificial intelligence is a key technology in order to enable this kind of reliable cyber monitoring for those IoT contexts. So this is really the key point if we want to offer new technology that are allowing to cyber monitor those kind of decentralized complex IoT systems. Thank you. So I keep around 10 minutes for the questions. So I will be happy to answer if there is questions.
Thank you very much, Paul-Emmanuel, for your very interesting presentation. If there are any questions from the audience, please raise your hand or write your question in the chat. Maybe I can start with a question from my side. It is, let's say, more general respect to the topics that you addressed in your presentation. And in this conference, we will talk also about infrastructures that can reconfigure themselves autonomously. To adapt themselves to surrounding environments. And these kind of infrastructures could be very important for managing easily critical infrastructures. The question is, what do you think are the major challenges in terms of security and privacy also for modern application where artificial intelligence takes an important role, especially in autonomous systems?
That's a very good question. From the security perspective, I see, regarding the two pillars I mentioned in the conclusion, I see several challenges. The first one is how I can trust any new assets that is coming into the systems. So this is really not that easy as it seems, because it could rely, if I take the industry example, it could rely in the provider you are using to put new assets. It could rely on the system itself, how you can ensure that a new component you start or you bring into your systems is secure. So this is really a key challenge. Then perhaps a threat really specific to the IoT is that when you bring an asset, a new asset or a new system into the system, you don't know its environment. Can we trust the environment where he is deployed? This is also a key point where I think that research also have its parts to play in order to bring solutions.
Also, the environment could be controlled quite easily from external, for triggering some external events, happenings, right? So if someone could have malicious intentions, could operate not on on the infrastructure itself, but on the environment in order to control
Exactly.
the infrastructure.
Exactly. That's the point with the IoT and the cyber physical systems. That it's not only the system itself, but the environment is key for the cybersecurity.
Okay, thank you. We have another question from Marco Jan. How do you see the role of open source in such security work? Is your implementation going open source?
That's a very good question. I think that open source is key because you have feedback from the community, and in this context, it's very important where we are talking about cybersecurity solutions. Regarding the open source release of this activity, it's indeed a way that we are investigating, and that really, I think, could be valuable for us and for the community.
Okay. Thank you, Marco. Did he answer to your question? Okay. If there are no other questions, are there other questions for Paul-Emmanuel? If not, I can say again, thank you very much to Paul-Emmanuel. Thank you for your presentation and for joining us for our conference.
Thank you very much, Enrico, for this opportunity to present this activity. Thank you.